in the video on rational functions and graphing, when I talk about n and m, I'm talking about the exponents. And the n is the exponent on the numerator. And the m is the exponent of the denominator. So just so that you're clear about what's going on. All right, so we're going to graph some rational functions. It's important when you're graphing rational functions to graph the intercepts, the asymptotes, both vertical and horizontal. Look at the symmetry of the graph. If it has symmetry, that's helpful in getting a picture of what goes on. And then you're going to plot some points. So let's try a problem here. All right, on page 268, number 30, this is a problem, and the directions are graph this. So, here, let's put this list over here so we can glance at it if we need to. So we need to find the intercepts. So the first thing you want to do is you want to do f of 0 of that equation. So f of 0 would be 1 minus 3 times 0 over 1 minus 0. And when you figure that out, you get 1 over 1, which equals 1. What does that mean in terms of a point to plot? 0, 1. You're going to plot the point 0, 1. So I have a graph here. So let's plot the point 0, 1. Over 0, up 1. That point right there. Okay. So we did step 1. Well, part of step 1, we found one intercept on the y-axis. This is the y-axis, this is the x-axis. So we found one intercept. All right, can we find another one? What could we do to find another one? We could take the top of the fraction, all right, and this is called the zeros of the numerator. So we could take the numerator, okay, the numerator, 1 minus 3x equals 0, and we could solve that. 1 equals 3x, x equals 1/3. So what ordered pair is that? Well, it's the ordered pair when x is 1/3, right? What is the y? We set it equal to 0. Okay, remember, right here, the y part was 0. So now we have another ordered pair to plot. At 1/3, about there, we go up 0. So we got 2 points on our graph so far. All right, so we did our intercepts. Next thing to do is the asymptotes for this graph. That's a little harder, but you can do that. So, to find the asymptotes, let's do vertical asymptotes. Here's what we do. We find the zeros of the denominator. Zeros of the denominator, and I'm just going to abbreviate that D. All right, so what's the denominator? 1 minus x. So 1 minus x equals 0. X equals 1. This is an asymptote, so we need to graph it. Where is x equals 1 on the graph? Well, let's look at the graph. Here's 1 on the x-axis. So where are the points for always x equaling to 1? It's the vertical asymptote right there. I'm going to let you know that it's x equals 1. So if we look back and need to find what we did there, that's a vertical asymptote. Okay. What else can we do? Okay, so after you get the vertical asymptote, you have to figure out the horizontal asymptotes. I think this is the most difficult situation because the horizontal asymptotes has three situations. Looking at the degree of the top or the numerator over the degree of the denominator. So, if you take and look at the degree of both, either you're going to have one is less, numerator is going to be less, numerator is going to be equal, or the numerator is going to be greater. If the numerator is less, the horizontal asymptote is y equals 0. If the numerator is greater, there's no horizontal asymptote. In our case, the numerator equals the degree of the denominator, so the asymptote is y equals some fraction, and you get the fraction by using the coefficient of the x term on the top, or the coefficient of the highest x term if you have more than one. So we have a minus 3 over the coefficient of the bottom, a minus 1. So our fraction, or our equation, becomes y equals 3. So we have to graph the line y equals 3. So let's go back to our graph here, and y is 3. So 0, 1, 2, 3. Y equals 3. This becomes an asymptote. So now we have our asymptotes up here, and we know we're going to have a curve. If you notice this x here, our curve could be here, or here, or here, or here. Usually it's in two of those places. So the last thing we have to do here is check symmetry and then plot some points. So how do we check symmetry? Do you remember how to do that? Okay, so here's how we check symmetry. There's two things I have to do. I have to find out what happens to the equation when I test f of minus x in the equation. It could come out to be the same as the original equation, in which case we have y-axis symmetry. It could come out to the exact negative of the original equation, which means we have x-axis symmetry, or both can be true, which means we have origin symmetry. If both of them are not true, then we have no symmetry at all. So let's see what happens on this one. So let's find f of minus x. So in this equation, I'm going to do p of minus x and see what happens. So I have 1 minus 3 times minus x over 1 minus negative x. I simplify that. This becomes 1 plus 3x over 1 plus x. Did that come out to the original? No. So, okay, so there's no y-axis symmetry. So now we have to check for x-axis symmetry. Basically, I do that by seeing if the equation is the exact opposite. So put a minus in front of the equation and see what happens. I like to distribute the minus to the top, so I'm going to rewrite it, minus 1 plus 3x over 1 minus x. And take this, the exact opposite of p of x is minus p of x, and it should be that. Does that come out to the exact opposite? No. So I do not have x or y-axis symmetry, so I can't have origin symmetry. So there is no symmetry at all for this equation. Okay, so the last part is just to plot some points. So make an XY chart like I did, and here are some points to try. I did 2, 3, 4, 5, then I decided to do 1.5. Plug those numbers into the equation. You guys can check it out with your calculator if you want. These are the numbers that I got. So, now I'm going to plot those. So, here's our graph here at 2. 1, 2, I'm going up to 5. 1, 2, 3, 4, 5, 2, 5. At 3, go up to 4. At 4, go up to 3.6. At 5, go up to 3.5. You notice as I go this way on the x-axis, it's getting closer and closer to this asymptote. It will not cross that asymptote. And as I go this way, 1.5. So 1.5, I'll go all the way up to 7. So 1.5, 1, 2, 3, 4, 5, 6, 7, all the way up there. So I'm getting steeper here. Again, approaching the asymptote but not crossing it. So there we go. Now let's do some points on the other side of the axis. So how about at -1? At -1 I get 2. At 0 I get 1. At 1/3 I get 0. That's an intercept. That's an interesting point. And at 0.5 I get -1. So let's go over here. At -1 up to 2. There's a point. Notice where my asymptotes are. At 0, 1, we had plotted that before. At 1/3, 0, we had plotted that before. At 1/5, I'm down at -1. So again, you can see we're approaching the asymptotes on this side too. Now, I also suggest typing the equation into your graphing calculator. Some calculators work best if you put a parenthesis on both the top and the bottom when you type it in. If I were you, I'd try it both ways and see if you get the same curve, and then you'll know whether your calculator needs the parentheses or not. So, there's the graph. So, graphing rational functions. Find the intercepts, asymptotes, both vertical and horizontal, check symmetry, and then plot some points. How did I decide what points to plot? I used my asymptotes as a guide, and then I made this chart with all the points to the right of the asymptote, and this chart with all the points to the left of the asymptote so that I could get both pictures of the curve. So, good luck with your homework.